Hey guys, it's Mr. Bosher, and today we are going to cover biconditional statements. Okay? Biconditional statements is really not much new. Let's get a stronger. There we go. A biconditional statement doesn't really add much new things. It's just taking what we already know and asking us to do like an extra step with it. Okay? So, what is a biconditional statement? And how am I going to tell if it's true or not, right? What is its truth value? That's what we want to know. Well, it's very simple. The word is biconditional. So we know that bi, B-I, means two. That's because we're going to only check two things. We're going to check the conditional statement and the converse. Okay? If these are both true statements, then we could say that the biconditional, we'll just do that for short. Okay, the biconditional will also be true. Okay? That's the main idea. So how do I know when a biconditional statement is true? The conditional statement, so our original statement, and our converse statement has to be true. Okay? How do you write a biconditional statement? If you notice right here, they don't use if-then. They use the words if and only if. This means that we're trying to see if it's biconditional. Let me try to write that a little bit nicer. Biconditional. Okay? So if you see a statement that feels like an if-then statement, but they use the words if and only if, that's a dead giveaway that it's biconditional. The usual question that you're going to get about a biconditional is if it's true or not. Well, how do I know if it's true? I need both the conditional and the converse statement to be true. Okay? That's basically the whole lesson. And now I'm just going to do two examples, just kind of show you, well, how do you go about checking that? Okay? So let's see. I want to just find out what is my original statement, and then what's the converse. Okay? Because I need to find those statements and write them before I can really tell if they're true or false, like we did in the last video lesson. So, let's erase some of this, get it out of the way. For our conditional statement, or our original, we're just going to keep it easy and use the same order. There we go. Use the same order that they used up here. Okay? So the original statement says an item is a ring if and only if the item is made from silver. Okay? So we're going to say item is a ring is going to be our P or the if statement, and item is made of silver will be our then statement or the Q. Okay? So that will be our original. So if I go back to the problem here, we could say, well, if needs to be the first part. So the item is a ring. There we go. Oh, there we go. Because I'm just following the same beginning as the biconditional, right? We're just making a really easy if-then statement based off the biconditional statement. Then the item is made from silver, because that was the second half they gave us. The item is made from silver. All right. Okay, so let's just review what I did. I said they gave me a biconditional. But in order to really understand this biconditional statement, I want to make it into an if-then statement because we've been practicing those. So I just said, well, I'm going to take the same order that they gave me to make my first if-then statement, right? So they said an item is a ring, so I put if an item is a ring. And then on the second half, they said the item is made from silver, so I said then the item is made from silver. Okay? Well, the converse, let's kind of review what the converse says. So the converse formula says that we need to flip the P and Q, right? Because converse almost has the word coin in it, and you can flip a coin. So we're going to flip P and Q. So it will look something like this. Q, then P, right? If Q, then P. Well, originally, we said that the if is an item is a ring. So if you notice, that's going to go in the second spot. And then our original then was the item is made from silver, which is now going to go in the first spot, or the if. Okay? So let's go ahead and write that. Again, if you're struggling on how to write statements still, I would go back to the lesson that goes over that, or the lesson that did practice problems over these. Okay? That was previous lessons. I'm not going to go into full details on this one. So let's go back. We need to swap our statements. So we're going to get the converse would be if the item is made from silver. That's how we're going to start it. Then the item is a ring. There we go. Okay, because I just swapped my if and then from the original. Now, part B wants us to determine if these are going to be true or false. Okay, so let's go back to where I can write, and let's test these out. So the conditional statement said if the item is a ring. So I'm going to go to my table, and I'm going to find out, well, where are all the items that are rings? If I look, I only have one scenario where that happens. Okay? Well, the second half of my statement tells me that if I get a ring, I should have that item made of silver. Well, if I look right to the right of it, it is made of silver. So the one scenario where I got a ring, it was made of silver. So is the conditional statement true? Absolutely. Right? Because there's no scenarios that can make it incorrect. Right? All of the scenarios do follow the statement. Cool. That one's out of the way. What about its converse, though? What if we swap the converse, what if I swap the if and then so I get my converse statement? Is it still going to be true? Well, let's find out. Let's make this one red. It says if the item is made from silver. So let's go through and find all the ones that are made of silver. There we go. That one is made of silver. And that looks like it, or that's all. Then the item should be a ring. So if I look to the left, it is a ring. So our only scenario does match our statement. So because there's no statements that disagree with our converse statement, then that one is also true. So because both of the statements are true, we can go ahead while we're here and say, well, what about the biconditional statement? Remember, if my conditional and the converse are both true, then my biconditional is true. Okay? Which is a very helpful thing in the math world. Okay, and I'll try to explain in a second once we just check that we got this all correct. Check. Perfect. Okay, so before I hop to the next question, let's kind of think about, all right, cool. There's a new statement called a biconditional. We know it uses this if and only if wording. And there's we know how to solve it, or we at least saw how to solve it. But why do we do it? Well, think about how we've talked about our main theorem so far is the Pythagorean theorem, right? So the main theorem we've learned basically says if, well, you know what? Let's use the colors I've been using. So my if is that I have a right triangle, then we know that this equation happens, right? A squared plus b squared equals c squared. And with finding distance, we've already seen where that formula is really nice to know, right? So that's a very helpful if-then statement, right? If I have a right triangle, well, then I know that I can use this formula. Well, then you need to ask yourself, would it be helpful for it to go the other way, right? Would it be helpful if it also does this? If I notice the equation happens, that also tells me it's a right triangle. Now, we don't know this yet, okay? Just to be clear. We haven't tested this, and this is something that we come to later in the year. We come back to Pythagorean theorem, and we ask this question. But we have to wonder, would that be a helpful thing? And maybe at first glance, you're like, well, cool, I know it's a right triangle, so what? The big deal is that we have a whole unit over right triangles with all the special things we can do with them. So if it's not clear automatically when someone gives you a shape if it's a right triangle, and you notice this, it might be really helpful if it does tell you it's a right triangle, okay? So why are biconditional statements great? Because if they go both directions, you can solve more problems. Because now you can have different starts to the problems, right? So far, we can only start things with a right triangle. Later on in the year, hopefully we'll find out if it goes both ways. And if it does, we can say, hey, I can start with the equation, and maybe it will tell me I have a right triangle, and then I've learned more things about those, and now I can answer even more questions, right? So that is the big thing in math, okay? Absolutely amazing thing in the math world. It might not seem like it right now, but as we get into theorems and we test them, we'll see that, man, it's really helpful when they can go both ways, and it's kind of annoying when they don't, right? So we try to see if we have biconditionals. All right, enough about the importance. Hopefully you'll more see the importance as we go through the year, if you're not convinced right now. But let's do one more, okay? Just so that in case you're like, I kind of got it, I'm not sure, we'll do one more. All right, so we have our table, and we have to do parts A, B, and C. And the very first part is, hey, here's your biconditional statement. It says a toy block is a triangle if and only if the toy block is blue. Okay, remember, if and only if this were on a test and they didn't already tell you you're checking if it's a biconditional, that's a big hint, right? If and only if. That means that you have to have the converse and the regular statement true. So let's go through and find what is our regular statement and what's going to be our converse statement. So just to kind of review, in my biconditional, we'll say that the first part of the statement will be our if, right? Or our original if. So we'll say toy block is a triangle. That will be P. Or you know what, yeah, sure. Or I'll just put P right there. There it goes. And then the second part of the statement will be our then. So the toy block is blue. So that will be the then or the Q. And we know that for the conditional statement, we want to say if P, there we go, then Q. And for the converse, we want to say if Q, then P. Okay? So our conditional is going to say if the toy block is a triangle, then the toy block is blue. And for converse, we're going to swap that and say if the toy block is blue, then the toy block is a triangle. Okay? Again, we should be kind of pros at this by now, so I'm just kind of speed through that part because it's not the part I'm concerned about right now. So let's see. Conditional statement. We said the if is the triangle, and the then is that it is blue. Converse, we're going to swap those. So converse is if it is blue, then it should be a triangle. All right, cool. We have that. Now part B is where we need to start to focus, right? Because we need to figure out, well, is the conditional statement true? And is the converse true? So let's go ahead and do that. Let's go ahead and go to where I can write. So conditional statement said if the toy block is a triangle. So let's go through and find my triangles. Looks like I only have one. And I need to check, is that one going to be blue? Well, if I look right next to it, that is blue. So our conditional statement doesn't have any examples that sort of disagree with our statement, right? It always works. So we're going to get a true conditional. For the converse, let's go ahead and get rid of this. For the converse, it wants us to start with asking if a toy block is blue. So I go to my colors. I have one situation where it is blue. And I want to check if it is a triangle when that happens. And yes, it is. So that will also be true. And because both are true, my biconditional is true, right? If both, just to review, the conditional is true and the converse is true, which is what happens, then my biconditional is also true. All right, before I end this video, let me see if I can get you at least one example where we get a false biconditional, just so that you see it in case you're wondering and you don't see how that's going to happen, okay? So let's check this. Awesome. Let's see if I can get one that would be a false one. The candy is caramel if and only if the candy has 300 calories. No, let's do a different one. Candy is chocolate if and only if the candy has 250 calories. Okay, let's do this one. All right. So first things first, I'm going to speed through the statements. Like I said, we should be pros at this. If you need more help with this, either send me a Canvas message or rewatch the videos, alright? So, first of all, it says a candy is chocolate if and only if the candy has 250 calories. First thing we should recognize is they use the words if and only if. So they're hoping that this will be a biconditional, right? Because I can only write the words if and only if both sides are true. Okay? So we're going to check. Is this true, right? Can we use the if and only if here? Well, let's see. If I follow their order, the conditional statement should say, if a candy is chocolate, because that's what they started with, then the candy has 250 calories, because that's what they ended with, right, for their biconditional. Cool. Converse just says flip those. So the converse is going to start with the 250 calories and end with the chocolate. Awesome. We should know that by now. Now we want to say, okay, is this really going to be true, though? Because I got to check both statements. So let's go ahead and try that. Conditional statement says, if a candy is chocolate. So I go and I find my type of candy is chocolate. And what do I want to happen in this scenario? I want the candy to have 250 calories. So I go over and I look. Cool. That checks out. So our conditional statement is true. Nothing breaks the conditional statement. Awesome. Well, now let's try the converse. Let's get all of this out of the way. The converse says, if a candy has 250 calories, so I'm going to go to my number of calories, and I see I have two scenarios where that happens, then the candy is chocolate. Well, one of them goes to chocolate, but the other one does not go to chocolate. So this would be false, because it doesn't work all the time, because I can also get cinnamon. So if I go back and I reread the original biconditional, this if and only if doesn't really make sense, right? Because what if and only if means is that this is the only scenario, right? A candy is chocolate only if it has 250 calories, which means that anything else with 250 calories cannot be chocolate, right? Like, it absolutely has to be chocolate or else it's not 250 calories. That's how they phrase that when they say if and only if, right? Chocolate is the only thing with 250 calories, and 250 calories, it can only be chocolate. It can't be chips, it can't be a drink, it can't be anything else. It is only that thing, okay? It's very specific. And that's another reason why we like biconditionals, is that it gets straight to the point, right? This thing only does this thing, okay? But in this scenario, 250 calories does not only go to chocolate, because if we look, it also goes to cinnamon. So the only here does not make sense. And so when we look at it, we say, well, is the biconditional statement true? Well, no, because look at this. They don't agree, right? One of them is true, and one of them is false. I need both to be true. So my biconditional statement is false, because they did not agree. Okay, so if I go back to your Alex problem, we said that conditional's fine, but the converse did not work. Come on. There we go. So the biconditional should also not work. So if I check that, there you go. So that's an example of what a biconditional is false. Okay, one of your statements still works, one of your statements does not work. Okay, so we can't use the word only because that's not the only possibility, right? It does not go both ways. It can go one way and work, but it can't go the other way. All right, so there is a biconditional. Goals for that was that if you can tell me if it's what a biconditional is, if you can tell me if it's true or not, and if you know the importance. Okay, the importance you might not fully see right now with just the Pythagorean theorem, but hopefully as we go later in the year, you'll start to realize, like, man, it would have been really nice if that could go the other way. And when things don't, it's like, man, that's kind of annoying, right? Like, it'd be really helpful if we can get them to go the other way. So as many things as we can get to go both ways in a theorem or if-then statements, the better. Okay, so that's why we got to get familiar with it. But all right, if you have any questions about it, send me a Canvas message. I can try to do some more practice problems and explain it in a different way. But other than that, you can go ahead and start the assignment. Good luck and have a great day.